So today I will just give you a brief introduction on RDS and the motivations behind it. So first of all, why do we actually get into trouble of working with linked open data? So if you're very new to linked open data, it is basically a way of defining and publishing data so that every piece of data is defined by a URI. And here are two statements, so-called triples. And this URI, which ends on Q153032, identifies Lisa del Giocondo, or this entity with the which ends on Q5 refers to a human. So we have two statements which just say Lisa del Giocondo is a human, and Lisa del Giocondo has the label Lisa del Giocondo. And if these URIs are dereferenceable, which means you can enter them in a browser, for example, you get more information about the content of this, or the meaning of these triples. And we can connect several triples to form a graph. And this is basically what we nowadays also call a knowledge graph, very briefly, linked open data. And why do we want to use that? For me personally, there are some good reasons. The first is to make data truly shareable and reusable. And very often when you work with data, it is buried within software. So you might have a database that actually contains the data separated in different tables. You have a software that connects everything together, and you have an interface, user interface or API with which to access it. And what it results in, it becomes very hard to access just the data without going through the software. And very often, you know, even if you have like a way of exporting the data, there are always some things missing which are not represented, which are represented somewhere in these other layers of software. So if you use linked open data, you basically can store everything in the data. You can connect data with each other, and you can use standard interfaces to query this data. It is also very useful for research in the humanities because it encourages the use of reference data. It doesn't require it, but if you already need unique URIs, unique identifiers for everything, you might as well use the ones which are already there. And we very often see in databases, for example, several text fields, different spellings used for the same artist, for example. And if you use linked open data, you're very much encouraged to use unique identifiers, and that makes it much easier to work with the data. And you get additional data, so that's another benefit. You can dereference, query this data to get, for example, birth dates or other additional data about the entities you link to. An important one for me personally is what I would say focus agnostic. So many cataloging systems, but also many catalogers work with a fixed hierarchy. So you have a painting, that's your entity. And you have, for example, a field for the artist, which is Leonardo da Vinci. You have a field for a subject, which is Lisa Gherardini. And that very much reflects, you know, the way something is cataloged. But that might not be the way you actually want to use the data, or someone else wants to use the data. So maybe you're much more interested in the relationship between people, between artists who are depicted, who have created a work. And with linked open data, because everything is an entity, you're not fixed with these hierarchies. That's why, you know, this graph is so important. You can rearrange this graph and, for example, you know, use a collection of artwork to make research into social dynamics and just kind of, you know, shape the data according to your research interests. What are some of the challenges when working with linked open data? Well, first of all, it's turning your data into linked open data. You might already have, you know, data tables, images, databases, how to actually create URIs for everything, how to make these connections, how to decide on the data model. These things are not trivial, and there's not kind of standard recipes for doing that. How to actually link data. You know, it's trivial to find a Leonardo da Vinci, but sometimes it's not very trivial to find the actual entities to link to. So which person in my database corresponds to a person in another database? Does this person already exist somewhere, or is it someone new? So actually creating these links is not always it's not a technical endeavor, but it's very much a research endeavor to identify the proper things to link to. And finally, publishing linked open data. You might have seen, these visualizations of the linked open data cloud where everything connects neatly, but how to actually get yourself known to this linked open data cloud, how to publish it, and if you link to a data set, the link only goes one way, so you're not getting noticed. So how actually getting your data published and noticeable. So these are some of the challenges that we also look at into this during this workshop. So turning data into linked open data is very much on day 4, where we look at linked ETL processes. And the problems of linking data and publishing data were some of the motivations behind the RDS systems. And this is what we're covering today and in the next 2 days. So why we are getting into the RDS project, I want to look at an example of one of our own projects, the Bilder der Schweiz Online. So Bilder der Schweiz Online is a project called Images of Switzerland, and it assembles a corpus of historical depictions of Switzerland from the early 18th century mainly until the mid-20th. And it stems, the material stems from 3 different collections from the Central Library of the University of Zurich, the Swiss National Library, and the Foundation Stiftung Familie Fehlmann. And what we want to do is we create a knowledge graph of these images, of this data, so we can find new, answer new research questions, but also make this material available for teaching and learning. So we already implemented a pipeline. We take the data from all these data sources in different metadata formats, image files, and we convert it onto a CDOC RDF graph. And in between, you see this little human, we link it to entities, to reference data. And the result is a platform which actually can already access where this data is available, where it can be queried via standard interfaces. And we have different views available. So you see the kind of standard record view of an image, but you can also explore the entire CDOC CRM graph, where it is very detailed and for different research purposes prepared. And we have a particular focus on geographic locations. We have many voyages pittoresques, which are basically travel routes illustrated. And we linked all the places to Wikidata, which then enables us to retrieve also the coordinates of these places. And we can see, for example, this travel route around the Vierwaldstätter See, which is called the Lac de Wallstatt. So we can see the locations of these images by getting the data coordinates from Wikidata. So what, in terms of reference data, were the challenges in this project? So first of all, really identifying the entities. We have many persons of the same name. For example, we have Gabriel Lori, both in the form of father and son, or père and fils, or life dates, or without. So finding out which entity, which person we mean was challenging in a lot of places in this project. We also have many Swiss artists, or Swiss practitioners, printers, engravers, which do not appear in kind of the big reference data sets like GND or Wikidata, but which do appear in more specialized reference data sources like the SICART Lexicon of Swiss Artists, which are, however, not yet available through standard interfaces in order to align them with our data sets. And we also found entities which are ambiguous, or which we cannot really identify, or which do not exist yet. And we still need somewhere to link to, and we still need a URI for those. And so the question is, how do we generate and how do we create those entities that don't yet exist? So this is where SARI RDS, the reference data service, comes in. So it's really something we developed to solve our own problems, but which we think is also useful for the community. What SARI RDS is, it's a service or an application built on the MetaFacts platform for cultural heritage and digital humanities. It supports remote reference data lookup, so lookup in different reference data sources. It comes with predefined forms for record creation, and it supports a mechanism for data publication. So the MetaFacts community is an application for building own knowledge graph applications based on templates and a variety of components. The data lookup in RDS, it supports an aggregated lookup across multiple reference sources. So you can query many reference data sources directly. We have some sources directly in the platform, and you can add more. And we also query Wikidata, which we don't integrate directly, but via lookup because it's so big. And we can also host new or custom reference data sources on our service. We have two flavors of the platform, the RDS local and RDS global. The instance that we host is the RDS global one, but you can also host one yourself. And this platform comes with predefined forms for creating entities. And we implement the SARI reference data model, which is kind of a proposed data models for many entities, persons, artworks, places, which implement a CDOC CRM data model. So without configuration, without being familiar with this model, you can use the form environment to create your own data and publish it as linked open data and compatible with CDOC CRM. And the data publication works from the RDS local instance to the RDS global via pushing mechanism. We see how this works in more detail, but this means you are in control of the data you publish online and make available for others to discover and query. So the problem of making your linked open data discoverable is implemented in this publication mechanism. So this is the way this works together. The RDS local, which is an instance you can host yourself, and the RDS global, where we have different data sets already available, for example, from GND, from ULAND, from GeoNames. And you can push data from RDS local to RDS global, or you can use your own RDS local instance to query your own data sets. So we will look at some configurations in the next few slides. The building blocks of this, so we have RDS global and RDS local, both build and implement the MetaFacts community. And on top of this, we add the RDS services, which integrate all of these mechanisms for data lookup and data publication, as well as separately RDS branding, which means you can also exchange these building blocks and apply your own branding, make it look how you want. And we have the two different apps, the RDS global app, which runs on our servers, which has this integrated data lookup and accepts incoming data, or the RDS local app, which supports data creation. And we publish two Docker images, the RDS global image and the RDS local image, which is what we will be using and what we'll be using in the hands-on session tomorrow. So again, some of the key features, both RDS global and RDS local, you can add any data set you want. So you can consume any data set in RDF, and with very little configuration, you can then use it to look up more data, or you can ask us to publish your data set on RDS global and make it available to everyone. So this is kind of a mapping to equivalent data sets. We have some basic data types like persons and places. So if you use a data model that we don't know yet, we just need to add a mapping to kind of the basic RDS person types. And one feature which we're quite proud of is entity grouping. So you might know that very often you have the same entities that appear across data sets. So here we have Leonora Carrington, artist, which appears in Wikidata, which appears in Getty, which appears in GND. And although these entities are linked, it's very difficult to kind of discover all of them. And because we have many data sets in our RDS global system, we can actually use these links between entities to find out which URIs refer to the same persons or concepts. And we make use of links between data sets. So of course, not all reference data sets contain link with each other, but for example, Wikidata links to ULAN, but ULAN doesn't link to Wikidata. But by using these jumps between data sets, we can actually make a good estimate of which URIs refer to the same things and present them as one grouped search result. This is a view of the data creation form. As I said, we can really create very easily based on forms, CDOC CRI compliant linked data with very minimal configuration. And the models that we implement, we already published on docs.wizardresearch.net. You're of course also free to use them in other contexts. These are some defined suggestions of how to model persons, places, artworks, events, etc. So how can you use it? Well, you can already use it today by going to rds.wizardresearch.net and use it to look up the datasets that we hosted. We have a web front end, which you can just use to query and discover entities in the systems. You can also set up your own RDS local system, which connects to RDS global, which means you can use it on site to look up entities on our online systems, but also to host and create your own data. You can also connect other systems to it. For example, RDS Global implements the W3C reconciliation API, which means it already works together with OpenRefine. You can integrate it as a reconciliation service to reconcile different entities in OpenRefine. You can also connect OpenRefine to your own RDS local instance. This is, for example, a use case where you have entities that we just discovered in our own data. We don't yet have reference data for them. So we can create them in our own RDS local instance and use OpenRefine to reconcile against our own data sets, but also against the ones stored in RDS local. So you basically can get reference data for everything you have in your data sets. And of course, because the reconciliation API is very well documented, you can also connect your own tool, your custom tool, to the RDS Global or RDS local service. For example, one thing we have not yet developed but intend to do so is a plugin for the TI publisher. It already has connectors to reconciliation APIs. So this is something where we want to add a connection to the RDS system, so you can use the TI editor to then add reference data and links through RDS local or RDS global. I'll risk a quick live demo. I hope not everyone is already on the site. So as I said, the RDS global system is already available. This is how it currently looks. We're working with advanced systems in Crete, so they have already implemented some parts of the RDS local systems, and they will also implement a bit more of the look and feel. But you can already use it. What did I show you before? Leonora Carrington, for example. I already looked this up, so we get a really quick result. It's a bit of cheating maybe. But here you see the grouping. We have results from Wikidata, from Getty, from GND. We have the description from all of them. And you can also expand it and look at the different data sets and descriptions. Let's try another one. So again, we see this is some entry finding all of them. Let's try one I haven't done before. So you see, we have a bit of a time for lookup. This is mainly because we also query Wikidata, and Wikidata we query via the endpoint, but again, we see the grouping works well. If you just want to query the local data sets, get a bit quicker results, that's possible as well. And you can select here different data sets. So this is already available, free to try, also via the OpenRefine W3C endpoint. I'll do a very quick demo as well of the RDS local system. So this is the platform which now runs on my own computer. So we can here also query RDS local and RDS global directly. So if I go in here and let's have different examples for myself. There we go, I get a result from RDS global. And I can also click here and enter RDS global. We haven't yet implemented the record views for the Wikidata, so that's why you don't see anything yet. What I tried before, RDS global. Again, I get the same results as an RDS global. And this is the system where we also implement the forms. So we have now persons, places, groups, build works, and artworks, all based on the SARI reference data models. Let's try to create a new person. And you'll see that we also integrate the RDS global lookup here. So if I want to get a new entity, let's just go again. I first query RDS global, and it tells me, well, there are already these entries available for a person with this name. And this is useful if you're not sure if an entity already exists. So you can then say, okay, actually, this is the person I mean, the SARI painter, and I immediately link to this person. Or I can say, okay, I actually have a new Leonora Carrington, which is different from this one, and I create a new person. In this case, I just say, okay, I link to the Wikidata person. And then I can, have other fields. I add my own name here. I have different fields, for example, birth, death date. I also can select birthplace. If I say, okay, I don't know, I wasn't born in Mexico City, but if I want to enter this information here, I can also use the place lookup to find places on RDS Global and directly link to them here. I can add another person, etc. And I can save this to my RDS local instance. So you might have seen this pop up here. We also have a workflow system here, which means you can also use this system to collaboratively create reference data, and then, for example, assign it to someone to check. And mainly this is in order to make sure that when you then finally go and want to publish data to RDS Global, you have control over which entries are actually pushed to the RDS Global instance and which one are still in your system. So you see here we have two entries, one which is already in state of having been accepted, one which I just created, which is in the review step. And if I were to push the data, I will only push the approved data to the RDS Global. So this is for kind of, making sure that you actually only publish what you want to publish.